Fellow chemistry enthusiasts, this is Montfort ChemPath here, and in today's video we'll be talking about the mole concept. This video is just an introduction into the topic, right? As in the future I will be uploading more videos covering more complex concepts covering this topic. So when we think about moles, right, what comes to mind is a counting unit. It is basically a counting unit, right? Though many students struggle to understand the whole concept of moles, it is important to know that when we speak of a mole, we speak about a counting unit. Just like if I say how much items make a dozen, 12 items make a dozen. All right. So just like that, chemists use the concept of moles, all right, to calculate how many particles are in a substance, right? So they say that 1 mole is equal to 6.02 times 10 to the 23rd particles. And this number is known as the Avogadro's number. So to understand the depths of this topic, there are some key terms you must be acquainted with. One, what is a mole? A mole is the amount of substance that contains 6.02 times 10 to the 23rd particles, right? These particles could either be atoms, it could be molecules, or it could be ions. The Avogadro's number or constant, it is the number of particles within 1 mole. So as I previously said, 1 mole is equal to 6.02 times 10 to the 23rd particles. The molar mass of 1 mole of a substance is in grams. For example, if I have 1 mole of carbon, that tells me that there's 12 grams per mole, or 12 grams, within that 1 mole of carbon. Right? So too with water. If I have 1 mole of water, it is considered to be 18 grams, of water within that 1 mole. Particles, right? Previously said, particles are just entities counted by a mole. It could either be atoms, it could either be molecules, and it could either be ions. Next key term we must be acquainted with is relative atomic mass, or the RAM. The RAM is the average mass of 1 mole of an element compared to 1/12 of a carbon-12 atom. So for example, let's say if we have chlorine, right? We have chlorine. Chlorine, the RAM of chlorine will be 35. How we come about with this value is because chlorine has 2 isotopes, right? And if we want to find the average of something, we basically add the masses of the 2 isotopes and then divide it by 2. And then we found that the average atomic mass, or the relative atomic mass, is 35.5, right? Because it has isotopes. Not all elements has isotopes. So for some of the elements, you have to find the average RM of them, and some of them you don't. So let's say we have a molecule like water, H2O, right? The RAM of hydrogen is 1, and because there are 2 atoms, right, since there are 2 atoms of hydrogen in this molecule, we multiply by 2 and then we add it with 1, because there's 1 atom within this molecule, times the RAM of oxygen is 16. So when we do the calculation, we'll have 2 plus 16, and the RMM in all will be 18. So clearly we could see we add the different RAMs of the element, and then we add them together to have the RMM of the whole molecule. So now that we know, right, about the key terms, we know the brief introduction, we could now apply chemistry in it by calculating the number of moles within. So now that we have a clear view on these key terms, we can now dive into answering some calculated questions. All right, so the first question here is, how many moles are in 24 grams of carbon? The molar mass of carbon has been given to us, which is 12 grams per mole. So here we could see that one, there is a mass given, and two, there is a molar mass given as well. So the formula we use when a mass is given is N, which is equal to little m, which stands for mass, and the big M, which stands for molar mass. So what is the little m? We have 24 grams per mole, 24 grams, sorry, divided by 12 grams per mole. And if we plug this on the calculator, we'll find that our answer is 2 moles. That's how we write the unit when we're talking about moles. Alright, that's the first one. The second one is to calculate the mass of 0.5 moles of H2, which is water. Alright, molar mass of water is 18 grams per mole. So in this case, right, we are given moles and we are given a molar mass, and they want to find the number of mass within 0.5 moles of water. So we could use the same formula we used previously, which is N equals little m over big M, but in this case we're making little m the subject of the formula. So little m, which is mass, gonna equals to the number of moles times the molar mass. The number of moles in this case is 0.5 moles times the 18 grams per mole. And 0.5 times 18, if we plug this on the calculator, we will have 9 grams. A key thing to note in the first example, when we're doing our division, it is important to show our units. Alright, so here we see grams canceling out with grams, leaving us with moles. That's why we end up with 2 moles. Alright, how many water molecules are in 2 moles of water? So in this question, we haven't been given a mass, right? We haven't been given a molar mass, but all we have is the number of moles. Previously, as I alluded to, 1 moles is equal to Avogadro's constant, which is 6.02 times 10 to the 23rd. So if we want to find, and then I spoke about particles. I spoke about particles being in the form of atoms, molecules, or ions. So if we want to find the number of moles that involves particles, the formula is N, number of particles, equals the number of moles times Na, which is Avogadro's constant. So the number of particles is equal to, how many moles do we have? We have 2 moles, right, times Avogadro's number, which is 0.6.02 times 10 to the 23rd. And if we plug this on the calculator, we'll have 1.204 times 10 to the 24th. Alright, and it will be molecules because they ask of how many molecules. If they asked of how many ions, it would have been ions. If it was atoms, it would have been atoms. But since they asked for molecules, our answer or units has to be molecules. Right? So the fourth one, find the mass of 0.25 moles of CO2, which is carbon dioxide. They have given us the molar mass of carbon dioxide. So key thing to note, again, they have given us moles and they have given us a molar mass. So we're using the normal formula, N equals, but since it's mass they want us to find, let's just put M gonna equals N times big M. And in terms of how we find the molar mass, right? Not all the time they will give you it, but in case they doesn't give you it in the exam, to calculate the molar mass of a substance or of a molecule, simply we take in the relative atomic masses, right, and we adding them up like we previously did. So we have carbon. We know there is 1 mole or 1 single carbon atom in this molecule. So it's 1 times the RAM of carbon, which is 12, plus, let's put in our units to see what we are doing clearly, plus how many oxygen atoms we have, 2 times, which is 16, is the RAM of oxygen, 16 grams per mole. And then we have if we add 12 times 1 is 12 grams per mole, plus 16 times 2 is 32 grams per mole, and then the sum of that will be 44 grams per mole. It's important to show your units so you're gonna know the steps that you're taking. Alright, so we can see that we have the same 44 as in the question. Good. So we know the moles, we know the molar mass. So the moles is 0.25 times the molar mass, which is 44 grams per mole, and the answer will be 11 grams. Good. So the last one, how many moles of NaCl are in 117 grams? So we have the molar mass of NaCl, which is 58.5. So we could know that we have given a mass, alright, and we given a molar mass, and we want to find the number of moles. Our formula we're using is N equals mass over molar mass. Alright, the mass is 117 grams over molar mass, which is 58.5 grams per mole. Grams cancel out grams, leaving us with just mole, and your answer is going to be 2 moles. Right? So this is a basic introduction in calculating moles. What is the whole general idea of moles? And tips I would leave to you is to always write down your formulas. If you write down your formulas, you know what units you have to use and which values you have to use. You always check your units, right? Always check your units to see which formula to use. So if you see things like atoms, how many molecules, how many ions, you know you have to use the formula, the Avogadro's formula, in order to calculate the number of particles. If we have given grams, moles, you know we have to use the moles equals mass divided by molar mass, and depending which one they ask, you just make the subject of the formula. And remember, 1 mole is equal to 6.02 times 10 to the 23rd. And this brings us to the end of this video. If you have made it thus far, thank you for watching. I hope you find this video helpful. Leave a like, subscribe to see more videos like this, because this is just part 1 of the many videos I will be uploading covering this topic and other complex topics in chemistry. So I don't want you to miss out on these teachings and these topics. Share this video to whomever you feel it may benefit, right? And if you have trouble understanding chemistry, and if you think you need a little more assistance, I tutor chemistry online, right? My WhatsApp number is right there. So if you feel the need to have extra help, feel free to reach out. It is in my best desire to see you guys succeed and excel at your examination. Once again, thank you and have a blessed day.